Alrighty, we are multiplying powers with the same base. So before we just talked about 0 and negative exponents, now we are going to multiply our exponents when their bases match. First, our problem of the day, we're going to solve this, so we're going to get x by itself. We'll subtract the 7 over. So negative 3x is less than 35. Divide by negative 3. When we divide by a negative, we got to flip our sign. So x is greater than 3 goes into 35, 11 times with 2 left. So x is greater than negative 11 and 2/3. If we plot that on a number line, it's going to be between negative 12 and negative 11. It'll be an open circle and going to the right. Okay. Oops, that's not what I meant to do. So we're learning how to work with exponents. We're going to multiply powers that have the same base and simplify rational exponents. So when you multiply powers with the same base, you add your exponents. Let's look at why we do that. So if we had a to the third times a squared. Well, a to the third is really a times a times a. A squared is really a times a. Well, that just gives us 1, 2, 3, 4, 5 a's, so that's really a to the fifth. So without writing that out, we could have just added 3 plus 2, which is 5. But in order to do that, they have to have the same base. So if we had g to the third times h squared times g to the fourth, we can add the g's, so 3 plus 4, which is 7, but that h would just be tagged on to the end. So g to the 7th h squared. So looking at our examples, when 12 is the base, we add 4 plus 3, which is 7, so that'd be 12 to the 7th. Here, negative 5 is our base. We'll keep it in parentheses so we know that that negative is part of it. Negative 2 plus 7 is positive 5. With 8 as our base, 3 plus 6 is 9. Here, 9 is our base. Negative 3 plus 2 is negative 1, plus 6 is 5. Here, we can multiply. 4 times 9 is 36. And then the only part that really has an exponent is the z's, and they have the same base. They're both z's. So 5 plus negative 12, that's negative 7. And we know from our last lesson we can simplify that further because negative exponents you just flip, and so we'll put that on the bottom. So we have 36 on top, z to the 7th on the bottom. All right, here we're going to multiply. 2 times 9 is 18. 18 times 3 is 54. And then we'll add the ones that match. So a and a squared, a plus, that's like a to the first. So 1 plus 2 is 3. So that'll be a cubed, and then b to the 4th. Here we can multiply. 5 times 1 times 3, that's 15. And then add our x's. 4 plus 9 is 13, plus 1 more, 14. Here we can multiply across. Negative 4 times 7 is 28. And then, well, negative 28. Negative 28 times 2 is negative 56. And then we'll add the ones that match. So c to the third, c to the negative 2, that's c to the first. And then the d squared. If we multiply these, 1 times 12, that's 12. Add our j's, so 2 plus 1 is 3. And then k to the negative 2. We can simplify that negative exponent by flipping it to the bottom. So 12 j to the third over k squared. All right, on this one, 81 to the 1/4 power. We need to figure out what we can multiply by itself 4 times to get to 81. It's also the same as if you square root it and then square root it again. So the square root of 81 is 9. You multiply 9 by itself twice to get to 81. If you square root that again, you get 3. So if you took 3 times 3 times 3 times 3 4 times, you would get 81. So 81 to the 1/4 is 3. 16 to the 1/4, same type of thing. So square root it and you get 4. Square root it again and you get 2. if you took 2 times itself 4 times, 2 times 2 times 2 times 2, you would get 16. 27 to the 1/3, so a number you multiply by itself 3 times to get to 27, or the cubed root of 27, that would be 3, because 3 times 3 is 9, 9 times 3 is 27. 64 to the half, so a number you multiply by itself just twice to get to 64, that's the same as square rooting it. The square root of 64 is 8. This was supposed to say 64 to the 3 halves. So instead of having 1 half, we have 3 halves. Well, if 64 to the 1 half is 8, now instead of having 1 8, we have 3 of them. So it'll just be 8 times 8 times 8. 8 times 8 times 8 is 512. Back over here, 25 to the 3 halves. So first we want to figure out 25 to the 1 half. So like the square root of 25 is 5. But we don't have just 1 half, we have 3 of them. So 5 times 5 times 5. And 5 times 5 times 5 is 125. 27 to the 2/3, we found out up here 27 to the 1/3 is 3. So now we just have 2 of them instead. So 3 times 3, which is 9. 16 to the 3/4, if we found 16 to the 1/4, we'd square root and square root again, which gives us 2. But we have 3 of them, not just 1. So 2 times 2 times 2, which is 8. All right, with these, we end up having to add fractions. Remember, when we add fractions, we need a common denominator. So first, we'll multiply these two together. 2 times 3 is 6, but our exponents stay the same because they can't combine. So a to the 2/3, b to the 1/4. And then here, 1 times 5 is 5. This was supposed to be b to the 1/2. A stays the same, a to the 1/3, b to the 1/2. Now we can multiply these together. 6 times 5 is 30. 2/3 plus 1/3 is just 1, so a to the 1. 1/4 plus 1/2 is 3/4. So 30a, b to the 3/4. Here we'll just add our exponents. 1/3 plus 4/3 is 5/3. We can leave it like that. 2 times 2 is 4, and then we'll add our exponents with c, 3/5 plus 1/5, 4/5. We'll leave it like that. B and c can't combine, but we can multiply this b with this b. And then we add 2/3 plus 4/5. We would need a common denominator, which would be 15, so we would change our 2/3 times to 10/15, 4/5. We would multiply by 3 to give us 12/15. And then when we add those, we get 22/15. For c, we have to add 2/5 plus 9/10. We would change that to 4/10, the 2/5, take it times 2. And then plus 9/10, that gives us 13/10. So b to the 22/15, c to the 13/10. This is like the one above it, so first we'll take 3 times 7, which is 21. J and m can't combine, so j to the 2/3, m to the 1/4. 3 times 7 is 21. J and m can't combine, so j to the 1/6, m to the 3/2. Now we're going to multiply these two together. 21 times 21 is 441. 2/3 plus 1/6. If we got common denominators, that'd be 4/6 plus 1/6, which is 5/6. 1/4 plus 3/2. Common denominator would be 6/4 and 1/4, which gives a 7/4. So that's our final answer.